Hello everyone, I am Dr. Santosh Chachade. In this video, I am going to describe chemistry of alcohols, which I am going to make as simple as possible. Let's begin. As far as the alcohol is concerned, these are considered as a derivative of alkane in which one or more hydrogen of an alkane will become replaced by hydroxyl group. So basically, very simple example is there in front of you, ethanol, in which one hydrogen of an ethane has become replaced by hydroxyl group and resultant compound is called as ethanol. So there are other compounds are also there like phenol, which do contains hydroxyl group in the structure. So in order to differentiate between alcohols and phenol, as both known to contain hydroxyl group in their structure, somehow hydroxyl group in case of alcohol it becomes attached to aliphatic carbon, whereas in case of phenols hydroxyl group will become linked directly to the phenyl ring. So three structures are there in front of you so that we will be able to make out the clear differentiation between alcohols and phenols. First example, you could see aliphatic carbon is there to which hydroxyl group has become linked. In second case, hydroxyl group has become linked directly to the phenyl ring, whereas in third structure, in spite phenyl ring is present, OH group has become linked to aliphatic carbon, or rather more precisely I must say benzylic carbon. So first compound is ethanol, second is phenol, and third one is benzyl alcohol. So this is how, depending upon point of attachment or the position of hydroxyl group, whether it has become linked to aliphatic carbon or phenyl ring directly, that will decide whether the compound will be alcohol or phenol. Forward, there are different ways by which you can classify alcohols depending upon how many number of hydroxyl group are there, and second, depending upon to which type of a carbon it has become linked, whether primary carbon, secondary carbon or tertiary carbon. We will see depending upon how many number of OH groups are present, alcohol could be classified as a monohydric, dihydric, trihydric and lastly polyhydric. Name itself is explanatory. Mono means 1, di means 2, tri means 3. So depending upon how many number of OH groups they do contain, monohydric alcohol contains only one OH group in the structure. Simplest example is methanol, whereas dihydric alcohol they do contain 2 hydroxyl group in the structure. Trihydric contains 3 hydroxyl group in their structure, whereas polyhydric alcohols are the one which do contains more than 4 hydroxyl group in their structure, and simplest structure is sorbitol, which is there in which do contains 6 hydroxyl group in its structure. So as I already made mention, you can classify alcohols. We can classify alcohol based upon position of OH group, that is nature of a carbon to which it has become attached. So we can classify alcohols into primary, secondary and tertiary depending upon nature of a carbon to which hydroxyl group has become linked. So in case of a primary alcohol, OH group become linked directly to the primary carbon, that is the carbon to which only one alkyl group maximum will become attached, whereas in case of a secondary alcohol, OH group will become attached to secondary carbon, that is the carbon to which not more than 2 alkyl group will become attached. And in both primary and secondary alcohol, this example is there on the screen, ethanol and propanol, primary carbon and secondary carbon I have marked with the colored square for the sake of simplicity. Moving forward, tertiary alcohols, in this case hydroxyl group will become linked to a tertiary carbon. Example is 2-methyl 2-propanol. The carbon which I marked with the colored square is a tertiary in the nature, as it has got linked to 3 alkyl groups, and hydroxyl group has become linked to tertiary carbon. That's why this is an example of a tertiary alcohol. Thank you very much for watching my video patiently. If you want to learn chemistry in simplified manner, do subscribe my channel, share my videos with your friend and stay tuned.